All right, let's get this started. First thing we need to do is solve the inequality. We begin by subtracting 14 from both sides of the inequality to maintain the balance in an attempt to isolate x. We are left with negative 6x. The less than symbol drops down, and 56 take away 14 leaves us with 42. Now, in the next step, we're still isolating x. We're going to divide by negative 6. When you divide both sides by a negative number, it is important to remember you must flip your inequality sign. X is then greater than, you're left with the number negative 7. You could also get that same answer by reducing both the numerator and denominator by 2, 21 over negative 3, and that'll still get you this nice little negative 7. Next part, we need to graph the solution on a number line. I only have one number that I am dealing with. That number is negative 7. So I'm going to put one tick mark on here because we should all know where the numbers on a number line go at this point. It says x is greater than. It does not say equal to, so we do not color in. All right, that would be if it is included, if that had an equal sign. Greater than negative 7, greater than. You always shade to the right of a number on a number line when the symbol reads as greater than. It doesn't mean the arrow has to look like that, because if x is on the other side, it will look different. Last, we need to do the interval notation. When you have an open value, you use a parenthesis. So I'm going to start with negative 7 and a parenthesis, and I'm going until. Until when? Well, this arrow is indicating that we shade forever this way, so that means we go until infinity, and infinity always gets a parenthesis, and that is our solution to question number 1. Here we have our next example. Again, we are going to solve the inequality. We have a compound inequality. This means that we are isolating x in the middle over here. I'm going to begin by adding 5 to all 3 parts. Add 5 to all 3 parts. Negative 10 plus 5. Negative 5. Drop my less than or equal to. These are gone. I'm left with 4x is less than, and this is 25. Again, I'm still trying to isolate x. 4 is attached by multiplication. I get rid of it with division. Divide everything by 4. I leave it as a fraction. Improper fractions are fine. I don't flip my inequality symbol because I'm dividing by a positive number, so there is no need. And that is the answer to solving the inequality. We are finished. How does this read, though? This reads as x is less than 25 over 4, open circle, shade to the left. X is greater than or equal to negative 5/4, closed circle, and you're greater than, so we shade to the right of that number. Part 2, we have to graph on a number line. I have 2 numbers in my solution. I will have 2 tick marks. This one is smaller, pay attention, so you put them in the right place. That is 25 over 4 right there. Draw my circles to start. Now we said this one's open, so that stays. This is closed. I tend to always want to color these in now with a square block when they're closed. We remember to use brackets in our interval notation. We said we're less than this number, but we are greater than this number. That means my final answer is shaded in the middle. So my solution on a number line should look something like this. Finally, I have my interval notation. So I'm going to use a square bracket. My solution starts at negative 5 over 4 until 25 over 4 with a parenthesis. And that is my solution. So I have my interval notation. Should have separated a little more, sorry. Here is my number line and my inequality, and that's the end of that example. Last, we have an absolute value inequality. Our first step, we have 2 steps. First, isolate the absolute value, and then second step, set up your 2 inequalities. Those are the 2 main themes when solving this. So, solving the inequality, first step, isolate the inequality. I'm going to begin by subtracting 19 from both sides. That's gone. This right here leaves me with 45. I don't know why I started writing a 2. 45. here I still have the 3 in front, which is being multiplied by the absolute value, as though the absolute value bars are parentheses. We avoid distributing numbers into our absolute value, as it can oftentimes lead you to a lot of mistakes, okay? So we don't want to do that. Next step, since we just said this is attached with multiplication, we want to isolate the absolute value. We're going to divide by 3. So this and this reduce down to 1. We are left with 2x minus 5 inside our absolute value bars is greater than 15. Next, we are setting up our 2 inequalities. We have absolute value bars on the problem. You can learn it by understanding, learn it by memorizing and eventually understanding, however works for you. So if you want to remember, you have 2 absolute value bars, you're going to set up 2 equations, right, or inequalities right now. The inside stays the same. It's in this force field. Do not touch it. So it is 2x minus 5. In both, I promise, you do not deal with the inside. Same, greater than 15. You could also do change less than change negative 15. Gone over this in other videos and in class, so make sure you're doing this correctly. Now all we do is solve each of these, add 5, and honestly you're going to do the same thing there in a moment. That gives me 2x is greater than 20, divide by 2, and we are left with x is greater than 10, little squash, sorry, and here, add 5, add 5. I know this is 20, that is not negative 20. Think about things before you write them down. 2x is less than negative 10, divide by 2, divide by 2. That leaves us with x is less than negative 5. You do not flip your inequality symbol because you are not dividing by a negative number. It does not matter that the 10 was negative. So now we have 2 inequalities that we're going to deal with on our number line. So next step is the number line. 1 number line, 2 tick marks. Negative 5 is smaller, that goes on the left. 10 is larger, that goes on the right. They're both greater than or less than, so we have open circles. They do not get colored in. X is greater than 10. You shade to the right for greater. Less than negative 5. You shade to the left for less than. So what's going to end up being shaded based on this? Everything here and everything here. When we write our interval notation, we will use a union symbol. So our interval notation, from left to right, where do you begin? This is negative infinity, and that always gets a parenthesis until negative 5, parenthesis again, union 10, parenthesis until infinity. So forever there, the union is connecting both of those choices, those intervals, those areas that we have shaded to indicate the solution set. So my inequalities are finished in blue, my number line is here in orange, and my